Hopefully you're all here for my session, which is tuning and optimization for the cloud, basically. How many of you went to Michael Knowles' session before this one on building the perfect farm? Great. So Michael will talk you through a lot of things about the right way to do things, the best way to do things, the preferred way to do things. When we're talking about cloud services, things are slightly different because we have to think more about the reliability, more about the frameworks that we work within in terms of stability versus having the perfect farm. So you'll notice some trade-offs here when we're talking about things. But think in mind all the time, we're going to talk about some things like SLA and impact and service availability and customer expectations. We're going to talk about those type of things. We will also talk a little bit about the actual deployments that we do. I'm not, for obvious reasons, going to start going in deeply into depth into how we build SharePoint Online. That's protected IP, and I have to be very careful about what I show in that space. I'm happy to field questions on it. If you've got specific questions, and I can answer them, I will do. But just be bear in mind, you're not going to see really deep dive architecture here. It's going to be very, very generic. So just to let you know who I am. My name is Neil Hodgkinson. I'm a senior escalation engineer in the Microsoft Online team. So generally my role, if someone asks me to put my role in a nutshell, it's keeping Microsoft SharePoint Online online. So I deal with online escalations every day. We have customer problems, customer issues which potentially take down SharePoint Online. If any of you yourselves are BPOS-D or BPOS-S customers, and you have a serious issue that can't be resolved by the first line or second line help desk teams, typically it comes up to the team I work in. And we work a follow-the-sun approach, and we just basically keep the system running. I'm an MCM in SharePoint Server 2007 and also in SharePoint Server 2010. And I'm an instructor for enterprise search. Search is really my kind of speciality in terms of the technologies within inside SharePoint. And if anybody want to keep in touch after the session, or I've got a specific question you don't feel comfortable asking in the room, then feel free to email me or DM me if you wish to tweet that way. So in terms of objectives, things we're going to look at, I keep looking in front of the screen. I'm going to go stand over there. What we're going to look at is some decision-making processes. So how do we make decisions on what should go in the cloud, what shouldn't go in the cloud? How do we design and think about moving our own content into the cloud? And what processes do we have available to do that? Some of the options and pitfalls. So there are some scenarios, certainly not in the cloud space, where, for example, and I will apologize up front if I start talking O365 or BPOS-D, that's just because of who I work for. These rules apply generally to all online hosters. So if you work for T-Systems or Fujitsu or Accenture or any of the big hosting providers, apologies for not mentioning your company, the rules apply the same way. So this is more of a generic presentation. What we're not going to talk about is specifically any one hoster. So I've already said that we're not going to talk specifically about O365 or specifically about Microsoft. It's more in terms of generic terms, and it's not prescriptive guidance. So don't expect to walk away from here thinking, I can go away and build a cloud farm. It's more like I can go away and I understand the things I need to think about to build a cloud farm. Combine that with several of the other sessions that you're going to see today, this morning already, and later on in this week. All those combined will allow you to build the perfect SharePoint farm. So for online. So in terms of agenda, we've got a little bit of something for everybody. We're going to talk about migration, specifically migration for things like private cloud, dedicated space. Those are more complex than migrations when you're thinking purely about standard space. Again, the scenarios where you're just moving your content into a hosted provider. When you're thinking about larger scale or dedicated farms or private clouds that you may own as an individual company and have your content dedicated to that space, there's a lot more options, a lot more capabilities and a lot more flexibility for you. And we're going to discuss a lot of those options. In terms of deployment for the hoster, so we'll look at what if you are a hosting company? And just as a point of question, is there any hosting companies or people representing hosting companies in the room? So there's a few people. You be quiet. So there's some specific scenarios in terms of how Microsoft does things and how we build things, which I will talk about. And they are, as I said already, very generic, very applicable to anyone who's looking at building for the cloud, specifically in the hosting provider space. So first thing, I'd like to start with a couple of questions though. So anyone can give me an estimate of a percentage for that question? What's the percentage of US IT pros believe the benefits of cloud computing outweigh the risks? Anyone hazard a guess what the percentage of that is?
24.
Any?
19.
Less than 15? So we had two offers of 25 and 15. It's actually 17%. That's significantly improved from where that number was a couple of years ago. So we're moving in the right direction. But for some people that came as quite a surprise, because there's a lot of people, a lot of talk about the cloud, a lot of people want to move into the cloud, and yet the trust level of the cloud is still a lot lower than we'd like it to be, certainly, and other hosting providers would like it to be. And then what about moving mission-critical applications into the cloud? Software as a service. So taking your line of business, mission-critical platform, and giving it to somebody else to look after. Any thoughts on that one? 5%, 10%. So we had 10%. So again, still very, very low numbers. And when you think about it, you think about private cloud specifically or online dedicated space, the level of monitoring, the level of capability, the level of SLA that's given for those type of applications will be significantly higher than most businesses can manage themselves. Thinking back to Microsoft again, our SLA levels are so tight that I can't even afford, or my team can't even afford, to miss literally a minute a day. That hurts. Yeah, that ripples through the business, and we feel that, our customers feel that, and Microsoft feels it financially when that happens. So in terms of these type of things, accepting the privacy side of things where people have some concerns, in terms of availability, capability, performance, there's no reason at all why these numbers shouldn't be higher. They should really be higher numbers, and it's a trust issue. So let's think about what we can do. I mentioned already that people have these trust issues, and there are scenarios where you wouldn't want to move to the cloud. There are issues where you wouldn't want to move your data that has to be, for example, and one of the big things that comes in, certainly with the US, is the Patriot Act. So all the concepts of hosting my data in my country. Those are scenarios where cloud becomes not really applicable because whoever the provider is doesn't have a data center in your country, so therefore can't service your requirement. Other things, cost effectiveness. It isn't always cost effective, even though it isn't particularly expensive. Matt Groves is going to talk, I think it's either this afternoon or tomorrow, about the cost of Office 365, for example. And he's going to give you the numbers, how much it costs today to host in 365. Even though it's cheap, very, very cheap, sub $5, $6 per head, sometimes that isn't always cost effective. Because if you're a very large company, that's a significant investment. If you're a very large company that has a huge IT infrastructure already and you're very good at managing these type of things, it may not be the most appropriate way to go. So just bear in mind that there's a balance between giving something to everybody else because you think they can do a better job versus how much is that going to cost me in the long run. And those are all calculations that you need to build in when you're thinking about moving to the cloud. So having said that, just an overview. Anyone in the room not have an idea of what we mean when we say multi-tenant? Does multi-tenancy make sense? Yeah. So think about a SharePoint farm. You all should be familiar with SharePoint in the room. A farm that has multiple tenants, multiple companies, multiple consumers, all hosted their content on that space, all being segregated or isolated in terms of their content, in terms of their search experience, their user profile lookups, their security people picker scenarios. So in terms of the multi-tenant scenario, that's kind of just a brief overview of what we actually mean by it. So think about segregation, think about isolation. Slightly different from the dedicated space, and the dedicated space is where, certainly from a Microsoft perspective, right now we will host an entire SharePoint server farm, anywhere between 7, 8, and 40, 50 servers dedicated to one individual company, depending on the size, the data footprint, the number of users, etc. So how do we get there? One of the key things about migration is making sure you can get there intact. So one of the problems we see a lot of is people who move to the cloud often say, well, I got there, but all this stuff I've had to leave behind because I can't take it with me. My customizations, my data fields are different. I've got too many lookup columns in my lists that doesn't apply in the cloud. We don't support that type of level of complexity in the cloud. So from a dedicated space, I just want to go through some of the migration aspects and some of the things to think about if you're moving your content into a hosted environment. And it applies to private cloud and online dedicated space. We'll look at the processes. So we'll go through processes, versioning, I won't dwell on this slide, distribution, health of my databases, key thing to think about. Some of the customization aspects. What service applications can I move? If I'm running SharePoint 2010 on-premise today, and I've got my really rich service applications all populated up, can I move them? Can I take them with me? And that's something you need to think about. There's some you can, some you can't. What about authentication? And then tooling for shared platforms. So in the shared platform scenarios, we don't support things like just grabbing your content databases and plugging it into a shared space. That really isn't appropriate for that type of scenario. So we'll look at some of the tooling you can use to get there. So thinking about the process. This process is and again, it's derived from the way Microsoft do things. We think about the scenarios. I don't know if you can read this. But it's basically customer, hoster, and customer again. And it's about the responsibilities. And you'll see quite simply that the majority of the responsibility in terms of moving into the cloud, certainly from a dedicated space, lies with the customer. It lies with the end user. They're responsible for agreeing a migration schedule. How are we going to move? How are we going to get there? What's our process of moving X amount of data into the space? We need to prepare and validate that data, make sure it's all nice and clean, make sure it's only the data we're moving. Hosted space tends to charge either on a per user, and if not per user, certainly per megabyte scenario. You don't want to move all your archive rubbish into the cloud. It's just going to cost you money in the long run. So you go through a whole scenario, a whole flowchart process here. What type of data are we going to move? Are we going to move content databases? Are we going to move database just backups? Are we going to use STS-ADM backups? What are we actually going to move into the cloud? And then the lower level in the pre-migration phase is really saying, and how are we going to ship it there? So if I'm going to move into the cloud and I'm a UK customer and I need to get my data on a set of disks and move it into a cloud space in Dublin, for example, I'm not just going to hand over all my data on a set of hard drives and say, there you go, carry that off to Dublin and go and plug it into some servers. You think about encryption, think about capabilities, and think about how you're going to move it. So we can do over-the-wire move, we can do database plugin, we can do even take USB disks. So all the different hosting providers provide different ways of doing that. Then once it gets there to the hoster, they'll plug the data in, they'll move the data into your dedicated or shared space, wherever it may be, and then you have to test it. So this takes time, this whole process. Certainly again, coming back to the Microsoft experience, this can take up to 20 weeks in SharePoint dedicated space with Microsoft. Other vendors take longer. I know for a fact other vendors take longer. Some take much less. And it all depends about the quality of the validation that's taking place, the quality of the data that's being moved in. The key thing is to have a framework. As long as you've got a framework that everyone understands, it makes it simple for everybody, and then you just follow the framework, follow the process. And each of these different sections of the flowchart has a lot of sub-processes built into it. So once we go through that phase, just to think about the things in terms of the end user admin, this is just a slide I put in, really just to let you know from an online space in 365 again, the supported and unsupported things you can do. So we mentioned in the abstracts of the session was to think about the online administrator. So you are the administrator for your company responsible for your online space. This really is just a reference slide to let you know what we do and don't support in O365. In terms of the product itself, from a SharePoint perspective, most of this stuff applies anyway. The browser version, the client version, the Office version, it's all generic. So it's not really just O365, but that's where the slide came from. The grayed out stuff is really for if you're thinking about using Exchange or the link services online as well. Like I say, that's just for reference. And then how do we move things? And how do we think about where we're going? SharePoint version's critical. Most people, a lot of people I talk to, certainly in my former life as a PFE, they're we want the latest cumulative update, we want the latest bug fixes, we want the latest performance gains. That's a good thing, but it can be a negative thing when you move into the cloud. The cloud won't necessarily keep up with that kind of thing. Clouds have to think about, well, am I going to destabilize my customer environments by going to the latest CU? We've all heard horror stories of, oh, I installed the latest CU today, and then Microsoft suddenly announces a regression. Okay, you installed the December CU and UPA blows up. Yeah, we've all been there, we've all seen that scenario. In cloud space, we can't afford that. That would be a huge detrimental impact on customers. So you'll always find that most of the clouds will lag behind. So we have clouds in Microsoft that are at various levels of CUs, depending on the customer requirements. So if you're moving to one of those spaces, you can't just come along and say, hey, I'm in the latest all singing, all dancing April CU 2011. Can you go and plug this into your online farms, please? Because the chances are that those farms won't be at that level, which means you can't do DB attach, which means you can't do STS-ADM restores, because it isn't going to work. The process will fail. So you have to think about that, and think about if you're planning to go to the cloud, the first thing you should stop doing is upgrading your environments, because eventually you're going to overtake where the cloud is. You may even be ahead already. in which case we need to think about some other processes. Things like dependencies on bug fixes or functionality. So, for example, particular bug fix for the workflow timer service running. I'll talk about this one later. There's a particular bug that's fixed in one of the either December or February CU that if you're dependent on that because you're running a lot of heavy, intensive custom workflows, some of the cloud services may not be there. That's just a specific example. Certainly, I know there are some farms that we run which aren't there because the customer is actually dependent on something that we fixed earlier, that not was fixed, that it was something the way something behaved earlier that's been changed to behave the right way. But because the customer was very dependent on how it worked before, we've had to leave them at that level. So if they now come along and say, we've got a dependency now, but it's actually on a future state, you need to roll them right back and say, okay, well, think about the problems you had before. You now need to address those issues and redevelop your customizations and redevelop what you did before we can move you forward to this other thing that you need. So it's very, very complex. It sounds simple, what version are you on? But moving to the cloud is much more complex than that. Content distribution. So I mentioned already that we can move data. We can move backups, we can move SQL databases, we can move, you can use web service connectivity to move things. If you're thinking purely about moving content databases, you need to think about the general governance best practices which have been banged on forever with about SharePoint, about shape of databases, size of databases, health of databases. And we expect in the online space that if you're going to deliver us with databases to migrate into the cloud, you will have done that due diligence already. So the last thing we want to see is scenarios with massive databases where a customer comes along and says, hey, I've got this 1.4 terabyte content DB. Can you go and attach it to your farm, please? Oh, and by the way, it's one site collection. Those type of scenarios hurt everybody. The customer's been experiencing pain for a long time, no wonder, and then they want to move that to the cloud. Well, it's not the right thing to do. They need to think about breaking down their data, splitting the site collections out, or splitting the sites into site collections, and going through all the regular due diligence that you'll go through in a SharePoint governance program. Other things such as, does we support custom managed paths? Everybody I know who has SharePoint on premises usually has custom managed paths. If they're not using vanity URLs, they're using vanity custom managed paths. In online space, they may not be supported. If you attach a content DB into online space that doesn't have those vanity or custom managed paths, the sites won't import. All these little things just to think about when you're going through this process. And certainly from the hosting provider perspective, it is so painful because the last thing we can really do is go and look at your databases and analyze them before we attach them. We can't start looking for custom managed paths and looking for all the little things that you might have done. It's dependent on the customer to inform the hoster. This is how we build our farm. In most cases, certainly in dedicated spaces, there'll be some kind of due diligence done where the hoster may go and visit the customer site and then look at what they've done and run some tooling and custom discovery agents to actually find out what they're doing. But in a lot of cases, it becomes extremely painful and it hurts a lot. From the health of the database size, again, this isn't too much of an issue in terms of indexes and statistics because we'll fix these when we do the attach. When you do a DB attach, the database will bloat anyway. The fragmentation may occur because you can do a significant amount of read and writes to that database. So in terms of indexes and statistics, we'll always update those afterwards anyway. So, but it is important to think about it and shrink the DB. Think about the actual health of the database before you ship it. Don't ship a database full of orphans, for example. That's just going to hurt everybody again in the long run. Customizations. This is probably the single most important thing in terms of failure to get to the cloud in your time frame. Customizations, certainly from our perspective, development side, the significant development investment is required from a customer to make this work. Microsoft, for example, or other hosting providers will not redevelop your customizations for you. If you want that to happen, that's going to cost you an extra significant amount of money in consultancy time. So you need to think very carefully, my customizations, are they appropriate? Are they going to work? Do they adhere to best practice custom frameworks? Microsoft have released a tool called MSO-CAF, which is the Microsoft Online Code Access Framework, Code Analysis Framework, which you can download. You run it on your development machines. It needs to, the current version that we have needs to be, the development machines need to be able to communicate to online, and it will analyze your code for you and tell you if you're conforming to best practices, tell you if you're conforming to, proper disposal. It'll run the FX COP rules against your environment, and it works extremely well and gives you a report and tells you where all the problems are. If you're going to move to Microsoft clouds, you must pass this 100%. There's no 99% pass. It must be 100%. We recommend that if you're a private hosting provider that doesn't have a tool like this, use ours. It's also extensible, so you can plug your own rules in. If you've got your own specific requirements for your own hosted farms, you can plug your own rules into this system. The other thing about high-level designs, so when we have people moving customizations, not all customizations can come across in the right time frame, so we expect people to provide as well, here's our high-level design for this customization, which we know isn't going to work today, but we want to get it there tomorrow. So here's the high-level design, and then we'll go through a whole process of making sure that can work in the future state. Has anyone played with MSOCAF? It's good fun. If you're any developers in the room, test yourselves. It's interesting. My code falls to pieces. Okay, so one of the other things in service applications, I mentioned about moving your service applications to the cloud. If you've got a very mature SharePoint environment, so we're about a year after RTM now, there's likely to be some significantly well-developed SharePoint 2010 farms out there, or upgraded 2007 farms. Things like managed metadata, social DB, user profile DB. These are all things customers or people moving to the cloud don't necessarily want to throw away and start again. So if you're moving into dedicated space, why should you throw away your rich taxonomy that you developed in the managed metadata service? Why should you throw away your custom user profile information? It's not always a bad story. There are scenarios where we certainly, and again I can only speak for Microsoft in this aspect, but we will take custom service application databases and bring them with us into the cloud. So that is an option. It's usually we call a non-standard change. So a customer has to request it specifically. If there's no request, we just build from fresh. And then customers can use code to move things from one place to another. So you can always contact the web services to do that. Some things we won't do, and some providers won't do, is take your custom properties. So if you have, for example, in the user profile service, there was issues early on days with multi-line text fields, for example, in user profile services. We can't know that up front. Your hosting provider cannot know about these things up front. You need to let them know. You need to inform them about the things that you've done, the changes you've made, anything you've done in the environment that affects service applications, your configuration settings. Maybe you've modified the default load balancing configuration for Excel services, for example, to suit your deployment. You need to let the hosting provider know that. Otherwise, you're just going to get a default configuration. Okay, so it's just important to document your environment and make sure you bring everything forward. Otherwise, problems are going to occur. In terms of authentication and authorization, very, very simple in dedicated space. Whatever you had to start with is what you get to finish. Don't ship us a DB that's full of SID, encoded SIDs in claims mode and expect it to run in classic. Okay, and vice versa. Okay, you've got to think very carefully about that. So wherever you started from is where you're going to end up. If you want to then migrate later, using some web service communication to move data out from one place to another, that's perfectly valid. Most hosting providers have some quite tight guidelines and significant restrictions on authorization types. Other things to think about in authorization space. If you're going to be doing partner access, for example, and you want to allow your partners to communicate with SharePoint Online, that means we have to now start thinking about the whole federated authentication piece and trusting other STSs, other secure services to be able to authenticate those users. Microsoft will not be, again, Microsoft, but we will not be responsible for managing that relationship with your partners. Okay, we will trust you. If you want us to trust your partner, or you want your partner to trust you and then you trust us by default, or we trust you by default, that's something you need to handle externally. Okay, so just confuse myself a little bit there, but at the end of the day, we will trust the provider that you tell us to trust. If you want us to go outside that scope and trust other things, you need to manage that relationship. So you need to get your provider to trust you, and you trust your provider, and we trust you. Make sense? Yeah. Okay. So in terms of the shared space, then there's a little bit. Shared space is more difficult, certainly in terms of moving to a multi-tenant scenario. As I said already, we can't just grab your content DBs and attach them to the farm. We can't just take your STS-ADM backups and attach them to the farm. So in many cases, people who are working in the shared space, like in the Office 365 or the old BPOS, any old BPOS S customers in the room? Couple? Cool. So in BPOS S space, we can't just take your data and move it to the cloud. You need to think about migrating that data. You'll always be provisioned with a clean installation, A few of the vendors that provide tooling for that, and I've probably missed some out, and these are just in alphabetical order, they're not in any order of preference. So AvePoint, Metalogix, Quest, ThinkScape, Tsunami, to name a few. We have most of our customers that I've seen moving to shared space, certainly in the O365 beta scenarios, are looking at using writing their own tooling to just make use of the SharePoint Web Services, because it's not difficult to do. Most of them have developers in-house. It's relatively simple to do that process. Obviously, if you don't have the development skills in-house, make use of one of the providers. I don't think they're too expensive to use. One of the key ones to think about, though, if your provider relies on you deploying a component server-side, at least one of those vendors I know requires for certain things to come over, they require you to have a server-side component. We will not support that component. So you cannot deploy that in the cloud. Some other providers may do, Microsoft don't. Some other providers may do. So talk to your provider before you make that decision. So having said that, in terms of how we can move things into the cloud, and again, fairly straightforward, fairly lightweight, how are we going to build a cloud? So what if we want to be a provider ourselves? I mentioned if about three hands went up of people who actually are providers. Is anyone thinking about being a provider? Or going private cloud, for example? Building your own private cloud services? A few. So if we're going to move towards thinking about having a cloud service where it might be managed externally, we might manage it for somebody else and provide a private cloud service, we need to think about how we're going to build it. And in many cases, a lot of the concepts are the same. We've just kind of briefly touched on the areas of things like versions, distribution, etc. We're going to look at it from a different angle now. We're going to look at dedicated or shared, or really who cares? Why does it matter? The end user doesn't know. Customer doesn't really know. It's important from a business relationship perspective that the customer doesn't think they're dedicated when they're actually shared this infrastructure with somebody else. But that's a relationship and it's a cost discussion with the end customer. From a SharePoint architecture perspective, does it really matter? Is there anything a dedicated customer can do that a shared customer can't? And things you need to, we'll talk about a few of the things there. What about building it? What about disaster recovery? If I'm going to suddenly recover a content database, what if I've got more than one customer's data in there? What's the implications of that for those customers? What about versioning again? Content distribution, customization, service application, and authentication, authorization all play a part in this I want to build my cloud scenario. So thinking about the dedicated, shared, or who cares, dedicated gives us a few options. So increased flexibility for customizations. Obviously in a shared space, you can't go deploying a farm-level customization that's only going to be applicable to one customer, because you don't want everybody to get that customization or everybody to have the option of managing those features. Obviously, there are ways within SharePoint of hiding things and moving things away, making sure people can't see things. But when you start to deploy farm-level customizations, it does start to have an impact on every person on that farm. It's not just going to be isolated for an individual site or individual customer. Typically, dedicated space, we talk about larger scale per customer. In the new models, with the SharePoint 2010 models, certainly in the O365 space, we're talking about an O365 shared customer has up to 20,000 users. That probably hits 90% of all businesses in the world sit in the shared space in that scenario. Actually, some of our customers that we have today in dedicated space will fit quite nicely in that scenario, in a shared space. But it may or may not be applicable for them, and that's kind of a discovery thing that we're going through now. Considered more secure. In what way? Well, from a security perspective, people think, well, I don't want to share my data. I've got sensitive information. It's going to sit in a database with somebody else's. That's not so much of a concern because people understand the security model. SharePoint segregates your data. Where people get a little bit twitchy is things like search. So what if I'm searching all this content in SharePoint? So, for example, multi-tenant deployment of SharePoint is obviously in claims. You want to crawl all that content. You may have multiple tenants' data in your search indexes, all mixed together. There's no way in search to segregate that data into separate indexes. That's where we really fall down in SharePoint 2010. We cannot segregate that data unless we go to multiple search service applications. We don't scale to multi-thousands of search service applications in a single farm, so we can't go down that route. So from a security perspective, I see that as the only issue. The other services, for example, the multi-managed metadata service, the UPA, all have inbuilt segregation capabilities within the databases that support those technologies. Okay? They have the concept of a subscription ID. They have the concept of a site ID. In search, we mingle things together without that same level of restriction, to some degree. In shared space, so think of choices that you have for customizations, SharePoint Designer, sandbox-only choices. Sandbox, kind of, I think when Sandbox was first kind of marketed as being, hey, SharePoint 2010 is going to have Sandbox, everybody was like, yay, feel the love. Now it's, well, I can't do this and I can't do the other, and the access restrictions, and there's too much CAS, and I can't do this, I can't talk to these services. So it's more restricted than people were anticipating. Having said that, it does give you a significantly increased capability on top of, by comparison with SharePoint 2007. So a lot more you can do with it. Is it less secure? Well, no, not really, because we build on exactly the same technology. So people think about sharing their data and make it less secure. No, it's not true. Is it cheaper? So therefore, the hoster might think lower priority. So in the online space, think about Microsoft online space, SharePoint BPOS S, BPOS D. Yes, BPOS S is cheaper. Is it a lower priority? Absolutely not. If we get a severity escalation comes in off a shared space, it gets the same attention as a dedicated space. It'll have a dedicated engineer assigned to it, it has an SLA assigned to it, and it must be met. Yet we have not quite the same financial implications of failing that SLA, but we still have very tight controls. For example, in our space, if you request a site restore, we treat that as a severity A incident, okay? Because it's your customer's data that we have to protect. So there might be a longer SLA to actually complete the process, but as regards of actually actioning that process and ensuring it's completed successfully, it's treated as a severity A incident. Faster time to market is the key one. So in terms of O365, you can sign up and literally get online almost within hours, I think is the end game, but literally, certainly right now, if you were part of the beta, you'd be online within days. But really, who cares? Future state, single infrastructure. Everybody talks about 365 and 365D. Where's that going? Are we still having dedicated farms? Are we still having shared farms? The end game is to bring the whole thing into one infrastructure. It's obvious. It's the only way to go. No one can really, it's not sustainable to support multiple platforms when you go to extreme scale. We're supporting tens of thousands of businesses in our environments right now. To support that in the type of environments that we have, it's just not sustainable. The cost per head to support a dedicated farm is huge. We need to bring huge customers into a shared environment. It's the only way to make the business develop going forward. And I imagine every provider in the room is thinking the same thing. It's the only way to go. So how do we build these things? Like I said already, I'm going to talk about the generic side of things. I'm not going to go specific, but just to give you some inclination and some ideas of how we think about what are our thought processes to build the cloud. Dedicated space, SharePoint farm to support many thousands of users. Shared space, dedicated SharePoint farm scale to support many thousands of users. There isn't really no difference. When we build a farm in dedicated, we don't think, oh, how are we going to build it in shared? Is it going to make any difference? The key thing is configuration. It's not specialization. We don't build anything differently when we build shared space. Office 365 SharePoint, Office 365 dedicated SharePoint, the platform architecture, the server roles, the capabilities of those boxes, the scalability of those boxes, it's the same. We don't differentiate. So it means we can roll out significantly, or we can quickly roll out huge infrastructure very, very quickly, easily supported, because it's all the same. If I know server name this suddenly fails, and it's in dedicated space, and the server name with the same coding name fails, and it's in standard space, I know I can go to that box and find exactly the same things in exactly the same places, exactly the same amount of memory, exactly the same CPUs, no difference at all. And then finally, virtualization. So System Center Virtual Machine Manager is key to the whole thing. From our perspective, if you're using VMware, whatever the VMware tooling equivalent is, to roll out your virtual environments, the ESX environments that can support your farms, is key. for cost effectiveness and for speed, and certainly for time to market to get these farms live. So thinking about building it, we work on what we call standard building block mechanisms. And this is just an example. Things we think about in terms of a web server. So all of your SharePoint farms that you have in your environments today have web servers in them, or SharePoint servers. We deploy, and this is, again, just an example. It's not specific to any customers, but we deploy a minimum number of applications, a minimum number of services to make this thing work. And we find in our environments that having the sandbox code service on this box is useful. In some environments, you might not think that. In your on-premises environments, you might think, well, I actually want the sandbox stuff all segregated out of the way. For us, it works extremely well having our sandbox service local because the communication side of things is much quicker. We have no concern over spinning up extra processes on the front ends because we have significant amount of horsepower in those front ends to handle it. And the way we build these things, we just scale out. So we're going to talk about the scale out in a few minutes. One thing I've starred there, the Foundation Workflow Timer Service, depending on your CU, if you're pre-December CU, for example, the Foundation Workflow Timer Service needs to run on those boxes. If you run it on an application server that doesn't have the Foundation Web App Service running on it, you'll start to experience major issues with AWS Timer Service, consuming all of the memory on the boxes. So that's why I flagged it. In the ideal world, the Foundation Workflow Timer Service will not exist on this box. It'll be pushed off somewhere else because it is a bit of a hog in AWS Timer. In this scenario, it's a requirement because of this relationship with the Foundation Web Application Service. What does it give us? It gives us simple configuration. It gives us highly redundant design. We just deploy as many of these as we like. If we've got a customer that suddenly says, hey, I only got 500,000 users, we can just go, okay, well, 500,000 divided by X per web server gives us however many machines we need to roll. We clone them, nice and simple. Virtualized, just keep rolling them out. Very, very simple deployment. And they're easily replaced, obviously. If things blow up, we don't bother trying to fix them. We just destroy them and start a new one. It all comes down to this configuration, no specialization. It's simple configuration. It just works every time. You just roll out a new one. Same server name, same IPs, and off it goes. At the application level, we have two styles of application server. So we think in terms of two styles of application server. We have ones that we refer to as our heavy hitters. So these are application servers that have significant demand on CPU or significant footprint on disk or significant memory requirements. And the one that screams out, obviously, is search. Search from a crawler perspective, significant memory and CPU. Search from a query perspective, significant memory and CPU and disk. Okay, so these are our heavy hitter drive. These will have bigger disks, they'll have more memory, they'll have more CPUs. And if you see the services that are running on them, they're all the ones that are either heavy hitters in terms of the load that they require, or they're significantly complex, such that they have consequences when you replace them. So replacing the server that's running a user profile synchronization service isn't necessarily the simplest task in the world, not one you want to do every day. Replacing your search service, on the other hand, isn't too bad, as long as you've got the redundancy built into the service to be able to accommodate that. But it can cause issues, okay? Certainly with the database side of things. And again, we're all cloned. We have no concerns over replacing these boxes. We just have a sufficiently adequate process to be able to do it. The other application servers that we have are what we call the lightweight ones. Now, depending on your use of SharePoint, you may decide that some of these services are not actually lightweight for you. How do we deal with that? So think about things like the Word automation service. Anyone run that service live? Word automation. Not word viewing, but word automation. Okay. If you do, it can be a heavy hitter. Significant amount of a conversion of documentation from word to web can be quite heavy. But again, it's not something you do every day. So we don't consider it to be a permanently running heavy-hitting application. So we build this second tier out of our application 2 tier, things like Excel calculation services, the managed metadata service. And they tend to be, when you look at these services, by comparison with the first ones, these tend to be services that you'll configure and leave alone. So UPA, you deploy it in one place, you leave it to run. Search, query, and site settings, your query processors, your search server service, you turn it on, you don't tinker with it. You scale it and you build it to scale the first time round. With these applications, you might suddenly say, actually, well, Excel calculation service, we're suddenly going to have a load of new business analysts and they want to use Excel calculation services in a significantly heavier way than they did before. So what do? We just drop some more of these boxes on. If you drop another box in the farm with that number of applications on it and just turn them all on, there's no impact anywhere else. There's nothing else you need to do in SharePoint. If it was search, for example, you'd need to maybe play around with the topology and change things around. From a SharePoint perspective with these services, you just turn them on. I need more Excel calculation services servers. Okay, tick, off you go. So they're easy to provision. They're easy to replace. So it gives us something we can keep a handle on rather than having a more complex design. From the SQL side, we build SQL Server to a standard, and we'll look at some of the tuning side for SQL Server in a few minutes. But we build it very, very simply. SQL Server 2008 R2, everywhere. That's all we need. We use SQL mirroring, so we use the log shipping as well, and we'll come on to that in a minute. But basically, we build these things as principals or partners. We have a fixed database distribution pattern, so we know where our service databases are supposed to start. We know where our content database, in terms of their numbering scheme, so content 1, content 2, content 3, we know where they're supposed to live. Depending on the footprint or the size of the customer, we can build these out however big they need to be. And we have this database distribution pattern, so we know at any one point in time where that database started. Because of the nature of SharePoint and SQL failovers in SharePoint, it doesn't mean it's always going to be where we put it in the first place. It might be live on its mirrored partner. But we have the pattern. We have the ability to say, okay, I want to replace SQL Server number 4. What does that mean? It means that all of the databases that are supposed to be on SQL Server 4, we can fail them all over to SQL Server 5, replace 4, and off we go again and carry on as before. We have no concerns again. These are easily replaceable boxes. Very, very simple to do. Then when we come to scale them out, again we're virtualized. So these are our 4 roles. And we thought about how do we scale them out. And we got options. We could go virtual host this way with a lightweight front end and a heavyweight application server, a lightweight application server, and theoretically a heavyweight SQL box. That would seem common sense, but that gives us an implication or gives us a problem in that this virtual host may have different requirements in terms of memory and footprint to this one because of SQL. So we actually virtualize it the other way around. And what we do is, because we know we're going to have distribution of load, we say, okay, well, all of our load is now going to be on, most of our load is going to be on this guy, on this host. So we, instead of having a standard physical box for our virtual hosts, we have two types. We have our lightweight front ends that host our front ends and our lightweight services, hosted boxes. And we have our really heavyweight. These boxes at this end, you're talking like memory in hundreds of gigs and CPUs, multi-core CPUs, hosting our SQL servers and our heavyweight application servers. So all of the horsepowers at the back end. They are virtualized, which tends to raise questions about, well, do we virtualize SQL or do we not? And you could debate that till the cows come home, depending on who's in the room. What we find is, in online services, you have to deliver a minimum level of performance to keep the customer happy. If you're going to host these boxes, you need to deliver a performance that makes the customer happy. In this scenario, using the right underlying architecture of disks, so we're not saying this virtual machine and that virtual machine are suddenly sat on the same RAID 5 set, for example. All their data's on the same RAID 5 set. We're not saying that at all. What we're saying is we virtualize them on these boxes. The underlying disk architecture is significantly complex. So we do the due diligence piece. We put our SQL Server data, we put our SQL Server logs, we put our temp DBs all on distributed disks. They're all virtual. They're all multiple VHDs, but they're sat on top of high-performance disk infrastructure. So it gives us the performance we need. Obviously, I can't reveal that to you and what we actually do, but bear in mind, if you read SQL Server best practices, you know how to build SQL Server to best practice. We follow the best practice, and we recommend any other hosting provider would do the same. Always build it the same way. In terms of scaling it out then, we scale out in groups. So consider the scenario, the minimum SharePoint farm. In this scenario, 2 web front ends, 2 application servers, 1 heavyweight server, and a SQL box. If we want to say, okay, well, in fact, this wouldn't be appropriate for any one customer because it isn't big enough. But to move it on, we just go scale up. So we add more. Okay, we want to go further, we add even more. So whenever we're building out, we just build X number of these, or N number of these, to be able to scale out a farm to suit the environments we need to. This model is working extremely well, so we're somewhere up to kind of 500,000 now in terms of number of users on an individual farm. And it scales extremely well. We've never had to break our model yet. Behind the scenes here, we've obviously got SQL with its mirrored partner, with a backup drive. So there's additional infrastructure in here to support this. But the model in terms of scalability works extremely well. And we recommend it as a guideline. And at the moment, the architecture team in SharePoint Online are actually producing this as intending to produce this as a white paper, as a model going forward for any hosting provider. In terms of how we do DR in an online space, probably very similar to how you do it on premises. We have, effectively, at any one point in time, you could look and say, well, there is at least 5 copies of any one user's data live or available at any one point in time. We don't differentiate, again, between standard and dedicated. So in terms of, do we give preference to shared people who pay less, or do we give preference to people who pay more? We don't differentiate, and we don't recommend anyone else would. So if you imagine our live data centers over here, we've got our principal and failover SQL servers. We're mirroring between the two. That gives us our first 2 copies of the customer's data. We then log ship to a DFSR location, so we can then transport the data to our DR location and roll it onto our third database, so our secondary farm, gives us our third copy. The other 2 copies are all contained in either backups here, so we back up live, and we back up the backup. So, as I said before, we can't afford, losing customers' data means your business goes down the pan very, very quickly. We can't afford to be in a scenario where we have no customer data available, so we make sure that we've got, at any one point in time, we've got multiple places we can recover that data from. And again, good practice, good guidelines. We talk about things like, well, log ship your content DBs, mirror your other DBs. We follow the best practices in terms of saying, well, you don't mirror the sync DB, you don't mirror the log ship, the WSS logging DB, for example. All the good guidance that's in TechNet, we make sure we stick to that guidance as well. So we don't do anything special. That's a key differentiator. In 2007 times, we had to do all kinds of weird things. SharePoint 2007, hostname site collection mode, is horrific to manage. Data gets all over the place. You get bleeding in of data from different scenarios. You can't just rely on security groups to segregate your data, because people picker can go a bit nutty. In 2010, because a lot of that architecture and infrastructure is built for us, I think Spence is going to do a session either this afternoon or tomorrow on multi-tenancy. We can rely a lot more on the fact that our systems, without specific customization in dedicated and standard space, will just work out the box. Yes, there's other things we need to do. Yes, there's federated connectors. Yes, there's what we call dir sync, which pulls in all your user profiles if you're using standard space. These are not customized SharePoint things. These are just to make our business work. So in terms of the SharePoint deployment, if you can install SharePoint today, go away, take your DVD and install SharePoint, you can install SharePoint in the cloud. There's no difference. There's nothing really special to think about apart from the level of scale, how big you need to build it. Thinking about the data center, so I'm good for time, Sean. 10 minutes. Thinking about the data center, so we need to think about the old way. So this is your on-premise deployment. Imagine a scenario here where you roll in all your IT infrastructure, and this is your user load. So you quickly reach a point where you've got far too much infrastructure for your users. Okay, and that's very, very common. More so than this scenario, where you've actually got not enough infrastructure for your users, hopefully. And people start complaining about performance. So the idea of the online state is to do this. Thinking more towards things like, well, can we deploy SharePoint 2010 in Azure? Can we have dynamic SharePoint farms growing and building and deploying new ones on demand? It is a future state. It is a desired requirement. We will get there eventually. Today, it doesn't work. But we can think about this model where we only have the servers on live. We only have the servers online and the servers live that we need. If we know we've got a significant demand coming in, we spin more boxes up. Today, we can do it in some degree to web front ends. So we can monitor the level of performance requirement on the web front ends, and we can see, okay, we've suddenly tipped over 500 connections. We need to think about adding another one. And you can just enable it or put it into the load balancer. These are all things that require require processes, and generally require human interaction. In the ideal scenario, our load will just track our requirement. So or should I say our infrastructure will track our requirement for load. So we'll just keep monitoring, automated spinning up boxes on demand. And that's a kind of a utopian future state, but hopefully we'll get there eventually. Is anyone working with Azure? One? Does anyone know what Azure, does anyone not know what Azure is? Anyone using Amazon Web Services and web hosting? Okay. We need to talk, folks. Azure is cool. Okay, so think about the versioning then. So basically I said already about things that we've talked about this to a degree. Think about which service pack I need to be on, which CU do I need to run on. As a hoster, you have to think stability over functionality. You cannot afford to make that mistake. So as a hoster, you'll have a significant number of test beds. You don't want to run into the scenario where a customer comes along and says, I need the April 2011 CU. Okay, we'll install it. Oh hell, it's broke something else. That is the worst possible scenario for a hoster to be in. It destroys the customer's trust in your business, destroys the trust in you, and means that you're offline. Offline in many cases as a provider means it costs you money. Again, talk about customizations and functional changes for the version that you need. So think about, just be careful is the kind of the key method here, the key message here. Distribution, how many web applications you're going to host. Customers, you folks in the room, anyone got more than 10 web apps on a SharePoint farm? More than 5? Yeah, okay, that's even worse. Okay, so think about the scalability. Think about the functionality you need to offer. Online space, does anyone really need more than a portal, team sites, my sites, and partner access? Maybe a blend of the four. Maybe I want to run team sites in my portal. But if you can argue for a case where you need more than 4 web applications for 90% of all deployments in the world, I'd like to hear it, because you really don't in online space. Certainly not when you start to think about shared environments as well. Think about size of content databases you're going to support. Are you going to allow large site collections? Are you going to manage those site collections such that you push those large site collections into specific content databases? So you're not having huge site collections spread amongst small site collections. Again, it's the governance thing. It's all the SharePoint governance thing. Again, managing quotas, make sure you apply quotas to sites. Our online spaces without quotas is just a disaster waiting to happen, and it will happen. From customizations, I've mentioned MSO-CAF already. Think about monitoring. So when we're thinking about monitoring environments, make sure that you can capture the things that your customizations are doing. You don't just want random customizations right into the application log. That's the worst possible thing, because you flood your app log, you end up with no data to actually analyze in the rest of the farm if you've got troubleshooting to do. So when you're actually doing your monitoring, or your customers are writing customizations, force them to go down the route of writing to custom application logs, where you can then have your monitoring read that log. So SCOM isn't suddenly passing the whole application log to look for that one event. It can find it in a custom log very, very quickly and react. Mentioned already, the SLA is the king in many cases with SharePoint Online. We need to make sure we can react instantly to a problem. If you've got the right monitoring in place, you can react instantly to those problems and get the system back online as quickly as you need to. From a service application perspective, we talk about the trade-off. There is licensing considerations to think about. So if you're going to provide things like performance point services, Power Pivot, great session on Power Pivot coming up later from Sean. Office web applications, Office web apps. Everybody loved Office web apps until they realized they still need an Office client license to use it. Yeah? But we don't check that. There's no way for you as the provider to say, I want to check that the client that's accessing my system has got a license. It's all done on trust. You as the provider will be in breach of licensing if you offer this to a customer that you don't know whether they are licensed for Office or not. So just be aware of the license implications of Office web applications. It's great, works extremely well. It will get better. There's not the same, we don't have the dynamic multi-edit in all clients and in all online services, but it's a great application and people love it. They just need to be wary of it and wary of the consequences of using it. From an authentication and authorization perspective, we've mentioned this already. NTLM claims, one-way trust scenarios. So certainly if you're running private cloud, where your private cloud may effectively think about it purely as it's more or less an extranet for the customer, rather than being a true isolated cloud. Things to think about here. Well, where are my users? Are my users still in the corporate domain, or are they in the cloud domain? Ideally, they'll still be in the corporate domain where all their resources are and all their services are. So we're going to trust that domain. Well, one-way trust scenarios with SharePoint and search for specifically with search will give you headaches. You need to switch search into claims mode, and you need to go through a whole process to make the security trimming work. So they're all scenarios, well-documented scenarios. If you want to know that about them specifically, I can talk you through them, but they're just all things to think about when you're hosting private or even dedicated cloud, actually truly in the cloud. If you're having one-way trust scenarios with customers, be very, very wary of what you can do over one-way trusts. Reach back to those domains is just not possible. In multi-tenant environments, we support claims and federated auth, which is obviously the way to go. We don't want to support NTLM in a shared multi-tenant environment. If you're looking at O365, for example, and you're already a BPOS client, your BPOS single sign-on client won't work anymore. So because we federate truly with like Live ID or with whatever you want to use, but it's just a call out that stops working. And then in terms of optimization, just go through these very quickly. One thing, what's the single most important objective for a hosting provider to be wary of? I've mentioned this several times already, and it's SLA. Okay, 99.9%, 3 nines. People talk about 4 nines and 5 nines. Nobody gets 5 nines. 5 nines is like 1 minute downtime a year. That just isn't possible. Yeah, 43 minutes a month of unscheduled downtime. It still only equates to 3 minutes. Yeah, so talking about me. Start again. 3 nines. 43 minutes a month gives us only like 1.4 minutes a day of downtime possible for a customer, of unscheduled downtime. You think about your own internal deployments when SharePoint goes offline. How quickly do you get that back online? Can you get it back online in a minute? Usually not. 43 minutes is tight. That's a hard deadline to hit. In SharePoint Online specifically, we're quite proud of the fact we haven't breached this SLA in over 7 months. So we've managed to keep all of our customers happy for over 7 months without any issues. And even when we did, it was not our fault, as we say. Think about optimization, and these are just some of the things that we do, and we've kind of discovered, and one of the things that the team I work in want to do is kind of start blogging some of this stuff when we can find the time to do it. So web server layer, we have SCOM, that's obviously the SCOM management pack system. Everybody knows what SCOM is. We find it's not sensitive enough. It's too slow. We get an alert 5 minutes after the system's gone down, we're already in breach of SLA usually. That gives us problems. So we have a lot of synthetic testing. We do scenarios where we have scripts running on boxes, and I would love to be able to share them with you. They're just awesomely written. I can talk about the design of the script if you like, and you can do your own. Effectively, we have scripts that will do things like test the URL. Is it online? Can I access the page? Do I get the right payload back? Yes, no. I don't get the right payload back. Okay, the web server's down. Take the web server out of rotation automatically by communicating with either NLB or with the F5 devices. So it immediately pulls it from rotation, immediately takes memory dumps, immediately recycles the web services, brings the whole thing back up, and then tests it again. And if it works the second time around, it puts it back in rotation, and no one's the wiser. It takes about 60 seconds for one web server. If one web server goes out. Obviously, we've got multiple web servers, so we're online anyway. We're not really in risk of breaching SLA, but it gives us an ideal scenario where suddenly a web server goes down and you're not having to phone somebody. You're not having to raise a bug and say, can you just log onto that box and check it out for us? We do check it out as a matter of course, but it's dealt with as a kind of a lower severity incident because our monitoring capabilities take care of it. We manage the blob cache. Big issues with migrations, specifically people moving off Lotus Notes to SharePoint. Extremely long path names. When you take NSF files and smash them out into the depth of those things can actually be at, drop that into a SharePoint site, you're suddenly looking at URLs in excess of 300 characters. That's bad for SharePoint. It's bad for the web interface. It's murderous for blob cache. Because as soon as you hit an item that's that deep in SharePoint, we'll cache it, but we can't clean it. NTFS doesn't support that deep. So you suddenly end up with an orphan file stuck right down at the bottom end of a file structure that cannot be deleted. When the SharePoint service tries to clean up the blob cache, what happens? It falls over. You get a W3WP exception and you lose the web server. So we have custom blob cache ruling. Yeah, custom regex in the blob cache rules to prevent that from happening. Don't cache things longer than a certain URL length. SharePoint should really do it out of the box. Timer job tuning, configuration cache and database. Be very, very wary of this. The bigger your farms go, so we're looking at farms today, 30, 40 boxes. When the timer jobs kick in, that config DB is going to get absolutely hammered. Okay, when you suddenly run the My Sites cleanup job across 25 content DBs running on 15 servers at the same time, the config DB gets hammered. SQL needs to be very wary of it. It's no longer just a case of tune the temp DB. Think about your config DB as potentially being a significant performance bottleneck for timer jobs. And this one's as a killer. Anyone, if you're running forefront update for SharePoint, this one and this one together, if your forefront updates kicks in at the same time as a timer job on the same box, you'll run into a config cache corruption, which will also take down the box. So if you're running forefront by default, it'll update at 2 a.m. Check out your SharePoint timer jobs. Lots of them run at 2 a.m. Move it. This is a registry change. Move it. Otherwise, you'll run into major issues. And it's quite nasty. It's a horrible thing to diagnose after the fact as well. All you find is you've just got a completely flattened box, and it won't restart until you clear the cache. Application layer. So we look at things like the SharePoint Health Analyzer. Yes, it's great. Yes, it tells me great things about my farm. No, it doesn't tell me them fast enough. Okay, it's too slow. Okay, we look at things like UPA availability, search index partition management. So we manage our search partitions. Search is great because it's all highly available, and if a partition goes down, we don't care too much now because we've got all these redundant bits and pieces we can do with it. We have management agents running that check the search. So we can issue a search against a specific partition. We can query a specific partition on a command line to say, are you online? And if you're not, we raise it as a bug and we get it fixed immediately. So it avoids us having to wait for the SharePoint Health Analyzer to kick in and say, hey, we've got a partition down. Come and fix it tomorrow. Okay, so just be careful. Think about the things you need to make sure you're online for availability. We run search synthetics. So we run synthetic transactions that upload content to a document library. When it's crawled, we test that it's there. If it's not there, we send alerts. So if you're not quite the same, if we're crawling every 24 hours, for example, we know 24 hours later, but that's our SLA on search, for example. We only need 24 hours of freshness. We might need an hour of freshness for different customers. So having these synthetics means we're not waiting for the customer to say, I can't find my documents. We know day one, instantly we do a crawl, we know if search has failed or not, straight away. At the SQL layer, some interesting things in here. Obviously the key things that people talk about, rebuild your index, reorganize your index, run the upstate statistics job. If any of you have been to a SQL session with Kimberly Tripp, she's extremely, yeah, Marcel. She's extremely heavy on things like rebuild indexes, reorg updates. Things in SharePoint, because we're very GUI based, doesn't have a great effect generally, but it's important to make sure you do it because it will realign your data in the right order. The fourth item there, free proc cache, you might not be aware of. If, for example, you're running SQL Server and the statistics are not fresh, okay, and you suddenly run into performance issues, you run update statistics. Okay, my stats are updated, but my query plans are all using the stats from where they were before. So I now need to flush all my query plans to force SQL Server to recalculate all those plans to make sure that the work I've done in updating my statistics is actually going to have an impact. Free proc cache is server-wide, it is impactful. Your users will notice a very slight performance impact when you run it, because all of the query plans, whether good, bad, or ugly, are going to get blown away. And SQL Server will recalculate all of them. But it will recalculate them based on the right statistics, based on the correct distribution of data within the databases. So while you suffer maybe a minute or two's hit while SQL Server does its job, the net effect is a significantly improved performance longer term. Longer term. So we run that about every week, roughly. Set these trace flags up. So by default, SQL Server doesn't highlight deadlocks. One of the biggest single problems in SharePoint and SQL Server is significant deadlocking, specifically with customizations. Make sure you're tracking trace flag 122, because the deadlocks will just appear in the SQL Server log, and you'll recognize them straight away. 3626 is another important one. You want to know which clients are hitting SQL Server. Okay, very important. Any of your DBAs in the room will know this anyway. Sometimes it's not just the knowing is my SQL server under stress, but it's knowing which particular server is putting that stress on the box. Knowing that my UPA synchronization service is flattening the sync DB. Knowing that my search processes are killing the crawlers. Knowing which search server is actually killing the crawl DB can be important to understand how to relieve an issue. And then the key thing, distribution of databases, stands to reason. It's something we've talked about a long time in SharePoint. Make sure your databases are spread on the servers, or spread most appropriately on the servers. Don't host crawl with property DBs, with the admin DB on the same SQL instance. You're asking for trouble doing that. So just be very, very wary of how you host these things. Specifically with search, more so with the WSS logging DB, you want that thing in a separate instance all on its own. Maybe with analytics, but not with anything else. Otherwise, performance will just kill you. I think there's a session on SQL Server optimization, specifically for SharePoint, later on. But just be very wary of the service apps. Content DBs, not too much to worry about. At the SQL layer itself, again, we set min and max memory. Everybody does that these days with SQL Server. Make sure you've got the right amount of memory for SQL Server to use. Cost threshold for parallelism. The SQL Server defaults are not appropriate for SharePoint. Okay, SQL Server defaults for parallelism to 5 seconds. So just to let you know, what it is basically, this means it's the tipping point at which SQL Server will decide to say, okay, this query is not appropriate for a serial execution. I'm going to flip it to parallel. All of a sudden, it drops what it's doing and recalculates a parallel execution plan and delivers it. SharePoint, in the meantime, is sitting waiting and will probably actually get a query back in about 7 or 8 seconds. But because SQL Server says, oh, more than 5 seconds is inappropriate, I'm going to recalculate, you actually end up with default SQL Server settings. You experience what appears to be poor query performance in SharePoint when it's actually just a simple configuration change in SQL. Flipping that up to about 30 seconds allows the first query that hits SQL Server to execute, rather than having to destroy that query to create new ones. So it's quite an important thing to do. And then finally, maximum degree of parallelism, the max stop settings. If you look at SharePoint stored procedures these days, inside the stored proc, if the stored procedure will benefit from parallel querying, or parallel procedure queries, it will actually say so in the stored procedure. It will actually set the max stop as appropriate. What it doesn't do is set it, if any of the other queries that are older ones that have been inherited from SharePoint 2007, any of those we haven't reevaluated. They may also benefit from max stop. So we recommend that you set the max stop setting, and I apologize I don't put on the slide. We recommend that you configure the max stop setting such that parallelism is enabled for SharePoint. By default, it's off or it's set to the standard from the stored procedure. So the key thing is make sure you turn it on. If the stored procedure can't benefit from it, it will turn it off automatically. So you're not introducing any additional overhead by doing that. So we're just about out of time. So this was my kind of last thing I wanted to just quickly show you. You may have seen some of this stuff already in terms of how we build our data centers. The data center evolution for this is purely Microsoft's kind of scenario, but probably very similar to most modern data centers. Going back 20 odd years, maybe, we have this concept of 2 PUEs. That means that for every, this is power unit efficiency, usability efficiency. We're basically saying that for every megawatt of power that goes into the data center, we're using one of it on computers and one of it on heating control, or cooling control, should I say more appropriately. So we're inefficient in this scenario. As we go up through generation 2, 2007, we're now getting better. So we're about 60% more efficient. 2008, we went to generation 3 data centers. Anyone seen the online presentations of the Chicago data center at Microsoft? Where it's basically just a whole series of containers with a roof over the top. Is where we go to generation 4. So generation 4 uses these things called iPACs, where basically it's a box that's bigger than an average shipping container, contains about 30,000 blades. It's very, very high density, and it runs without cooling. It's extremely, extremely efficient in the way we actually handle these things. And we build them, literally they're built by the vendor, they ship them to the data center, they drop them in place and plug them in. It's as simple as that. Generation 5, on the other hand, will go one step further, nothing spinning. So we're already at the point where we're building data centers or starting to build data centers that have no spinning disks anywhere. Completely SSD or completely solid state devices of very obviously expensive, very high availability devices. The current level of SSDs, your commodity SSDs that you get off the shelf, aren't good enough. You'll pay significantly more for the ones that we're using, but it's really in its infancy at the moment. The cost is astronomical. It isn't cost efficient to do it today, but it will be going forward. When we put these things in place, we build this. So these are one of these iPACs opened up, Windows Azure, windowsazure.com, have a look. Racks inside, servers inside the rack, and this is how we run the thing. What we do is we just suck cold air through it, cold air from outside the data center. So one thing you'll notice with Microsoft, we're starting to build data centers in very cold places, or places that don't have high degrees of heat. Previously, we built them where it was cheap to build them, in the middle of deserts, like Arizona and places like that. Now we're building data centers in places like Dublin. Apologies if there's any Irish in the room, but Dublin hasn't got the greatest temperature in the world. We have emergency cooling if necessary, but typically 52 degrees is adequate. We run the highest level of server intake air temperatures in any data center in the world. So we're sucking in air that's already well above ambient temperature, and our servers run just fine with it. We don't need to think about sucking in sub-zero or really cold air into our servers to keep them running. When we build these things, these are what they look like. So they come in pairs. We have basically a server unit with an air handling unit and the air distribution unit alongside it. And these things are just dragged into a big space, sat on the floor, plugged in, and off they go. I think there's one more shot. So that's kind of what it looks like total compared to a man. So you get two of those things together, gives you a 30,000 server data center. And these are being built out all over the place today. And this is a model that, it's not just a Microsoft thing, all of the big vendors, the big data center providers will be doing the same thing. But it's extremely, extremely efficient. And to fit that many servers in a box is just incredible. Really, really high density. And that's me done.